to are in batch mode. So this is tetralyt. Good. Okay, so let's look at how to run R in batch mode. So one of the first questions is, what's a batch job? And how do I write a batch script and submit a batch job? So first, we will do a short intro to the Slurm scheduler, and then show some of the structure of a batch script. And then there will be some examples for you to try. Now, these project IDs will be more important because you need those in the batch scripts, also for interactive jobs and things. But for now, let's focus on the batch scripts. And here are for each of the different clusters, which project ID you should use. So when I say project ID, it's these ones I mean. And you are noticing that tetralyt and Darvel have the same, and that's because they are both NAISS systems. So they have a shared project on those, whereas the others have a local compute project. You can see what they named here. And as mentioned earlier, there's also storage space for the workshop. And here you can see how it looks at the different centers. And you notice here that Cosmos is missing. The reason for that is that they have 100 gigabytes in the home directory. So there is enough space there for us to run. So there is no need for project storage. But you have already tried going to this directory. And now when you installed our packages and things like this. So you already know about this. So let us continue. These are good places to go for refreshing yourself on the name. So how do the various systems look? And the one for UPPMAX will soon change in the sense that Rackham and Snowy will be retired and will be replaced by Pelle and Maya. But I believe the structure will be mostly the same, but that's something maybe Michelle can answer. Do you know?
No.
So, but let's for now assume that they will. And in any case, right now it's Rackham and Snowy, and it looks like this. So you log in from either an SSH terminal or with Thinlink. You log into the login node on Rackham. And from there, you submit batch jobs or interactive jobs to the calculation nodes, which also sometimes are called compute nodes. You can also submit them to Snowy. You cannot log into Snowy, that's a GPU resource. And you can do interactive jobs and you can do batch jobs to the calculation nodes on Snowy. And then there is Bianca, which is a sensitive data system, and we're not going to cover that today. There is separate courses for Bianca. So HPC2N is somewhat simpler. You log in from the terminal, from Thinlink, and in the future also from Open on Demand. And then you come to the Kepler-Kaiser login node, and you can make batch scripts or interactive jobs to the compute nodes. The interactive sessions works a little different at HPC2N, but we'll talk about that in a later session. On LUNARC, it is much the same as at HPC2N, except there is also a sensitive data section, which we're not going to talk of, but otherwise, you log in, you come to login node, and you submit jobs to compute nodes. And that's also how it works at NSC and also at Darvel. Again, the interactive jobs on Darvel is a little bit closer to at HPC2N, but they can also be used in a different way in that after you got the interactive allocation, you SSH into the compute node if you want to install it. But again, later. So why would you want to use a batch script? Why not just run it on the login node? Well, the thing is, the login node is shared by everyone. So if everyone runs long and heavy jobs there, then it will be completely clogged down. It will use up all the resources. So because of this, you must submit longer, resource-intensive or parallel jobs with a batch script. And the batch system at all the centers we are talking about here and most other HPC centers in Sweden is called Slurm. Slurm is an open source job schedule. It gives 3 key functions. Well, it keeps track of the available system resources. That is, how many nodes, what type of nodes, are there GPUs on them, how much memory, and so on and so forth. It enforces the local system resource usage and the job scheduling policies. So it also, that is something that will be a little bit different between systems. How is these policies defined? And then also it manages a job queue, it distributes the work across resources according to policies. So you submit a job, it goes into the job queue. And then it looks at the priority of this job. And that depends on the priority of your storage, your compute project. And this priority is partially dependent on how much allocation you have, how much you can run, but also on how long it's been since you ran something. If you have run a lot in it, your priority will go down. And then over time, it goes up again. And so people with higher priority will get jobs started quicker and so on. So the job scheduler handles all that. So to run this batch job, you need to create and submit a Slurm submit file. And if you Google these Slurm submit files, you will find that they can also be called batch submit files, batch scripts, job scripts, and even other things, I believe. But it's all the same thing. And there is a guides and documentation at each of the centers, and they are listed here. So the workflow is first you write your batch script. Inside the batch script, you do various things. You load modules, and you, if you have own installed packages, maybe you need to load an isolated environment. Maybe you need to set the rlibs user in order to get to my packages, etc., etc. And you ask for resources depending on if it's a parallel job or a serial lot job. Do you need GPUs, etc., etc. And then you give commands to the R script and submit it with sbatch and then the name of the batch script. Note that the batch script can be named as you want. There is no requirements for what you call it. It is common to put extensions like .sh or .batch, but it's not necessary. It's merely a way of making it easier to find in your directory if you have a lot of stuff there. But pick any name. These are conventions that you don't need to follow. So some useful commands. You can submit a job. You do that with sbatch and whatever you named your job. A job script. To get a list of jobs, you use the command sq -me or sq -u and your username. And to check on a specific job, you can do scontrol show job and the job ID. You get the job ID when you submit the job or from this command here, sq. To delete a specific job, you can do scancel and the job ID, or you can delete all your jobs with scancel -u and your username. You can use the sacct command to get some useful info about a job, and you can get a URL with info about the job by the job usage command on Kebnekaise. There is, I believe, a similar command on some of the other systems, but we haven't noted those down, and maybe some of the people who are from that center can tell me what they are. But I will just make an example here in a short moment. First, key points. Slurm scheduler handles allocations to calculation or compute nodes. Interactive session was presented, will be presented in a following presentation. We have moved things around. It will be later. Yeah. And batch jobs runs without interaction with the user. And that's important. So if you have submitted the job, then it will just run even if you log out and go and do something else. And the batch script consists of a part with Slurm parameters that describes the allocation and the resources you want, and the second part describes the actual work within the job. For instance, it could be one or several R scripts. And if you have arguments to the R script, like input arguments and things, you need to add it, because remember, there is no input to the job while it's working. Again, I repeat this thing about the modules on Dardel. If you need to use module purge, you should, as the very first thing after you log in, create a collection with the pre-loaded modules so that you can restore them. This is only if you have a habit of using module purge, which I do, because it's common to use them with the SPC20 and LUNARC. So let's go ahead and look at some batch scripts. And this here is an example. This is for UPPMAX, but there is very little difference. First, you tell it, I am going to run in bash, and that will be in each of them. -L is that it's using the login screen, I believe, for login shell for bash. So it runs some commands, sets some environment variables. Then you ask for that you tell it, I'm using this project. That line always have to be there everywhere, as you can see. It is this project ID we talked about earlier. So you're telling it, I'm running in this allocation. Then you tell it how much time do you think the job will take. This is an important thing. Asking for longer time will mean it takes longer for the job to start, because it's looking for a slot where there is that much time available on that type of resource you have asked for. It will, however, not take that much from your allocation. So, I mean, if you are asking for 4 hours, but the job only takes 5 minutes, it will take long to start, but when it does run, it will just use 5 minutes. If, however, you ask for less time than you need, you say, I just asked for 1 minute, but my job took 5 minutes. The job will start fast, but it will also end after 1 minute without your job having finished. So don't ask for too much, but also don't ask for too little. Some types of software can do checkpointing. We are not going to cover that here. There are many other things you can put into your job script. You can change how many tasks per core and things like this, how much memory. But right now we are just going to use this very simple example here. And since number of tasks per core is 1 as default, then asking for 1 task is also asking for 1 core. And it will work since this is a serial example. After you have told Slurm what resources you need, then you go on and load any modules you need. Here I load the modules and the prerequisites for R and SPC2M using R412. To run your R script, you could then do it like this, for instance. It's also possible to use the R script. And we will see several examples later. But before we do anything else, I am just going to go into these exercises directly and just untaught. I believe I untaught it here. Let's see. Not. So I will go into R. And here you will find a lot of batch scripts and also some R scripts. This batch script here runs hello.r, very short R script. And, the batch script to run this, you can either copy the one that fits your center and create it here, or you can open the one that's called serial.r. Sorry, serial minus your center.sh. So this is on Kepler-Kaiser. So I'm going to open this one here, and I'm going to open it in Nano. And you can see here, this is the same one. The only added line is this one here where I described what it does. And there is no need to change anything in this. So I'm closing it. And then I'm submitting it with sbatch. And then the name of it. This. And when you submit it, you get this here, that is the job ID. And when it runs, it will create a file that as default is called slurm minus the job ID.out. And we can open this file and see what is inside of it. There's currently nothing because it hasn't finished running. So let's see what is going on with this command here. And it has apparently now finished running. And now there's also something in it, as you can see. Yes, it ran and it has the output hello. Hello. Ignore these error messages here. They are caused by the module, so one of the modules I loaded for R, which disagrees with the Nano program. And it's, I believe, only at SPC2N. But this way you can submit a job. Let's submit it again. Let's submit several of them so that we have time to see that it is running. And here you see here, first, it's a little bit larger. First, there's a job ID, a list of job IDs. And after that comes the partition is running in, and that will vary between centers. This, in this case here at SPC2N, it's saying it runs on Skylake CPUs. There are also different types of CPUs, AMD 3 and 4. Then if you have given the jobs in a name, which you could, because if maybe you have a lot of jobs running for a long time, then you can look down over the list and find the one that is named the way you want to. You do that with hashtag sbatch minus J and then the name you want. But otherwise, it will just be named the name of the batch script. One thing to notice also is you see hashtag sbatch, capital letters always. Otherwise, the batch system will not recognize it as a parameter for the batch system. Then you see a list of users, that's me. And then you see the status, which is R for running. It could also be CG for completing or PD for pending, as well as a number of other ones. In the next column, you have time, which is how long has the job run. How many nodes is it using? Of course, it actually is. And what is the node's name that it is running on? And you can see it's different ones here. You can then do S control, show job, and then take one of the job IDs and look at it. And then you get a longer description of the job. And it is currently completed. But otherwise it would say here. It would also say when it is estimated to start, if it's pending, though that can change if other people who are currently in higher priority is submitting jobs. It tells you when it started, when it ended, if it has. It tells it how long it ran, and things like this. It also tells you which nodes it ran on, how many cores, how much memory, and many other things. So all of this is very useful. And you do it exactly the same way here on the pattern. Here, then that too will run. Probably already. It's pending, so many people are using it right now. But here you can see the state pending, and it doesn't yet have a time because it hasn't run yet. And it also don't know which nodes it's going to run on. But now it's already done. So, and here, no, CF actually stands for configuring, so it's starting to run. But it now has a node. So it's good. And you could test this out later here. Or you can also just test it out now, because I'm just going to do the same thing for parallel code. And they submit it in the exactly same way, and you test in the exact same way to see the output and things like this, and to see how it's running. But for parallel code, one thing to notice is that you will have to ask for more cores. And in this case, I'm also actually, because of this for each and do parallel, they need somewhat more memory. So you need a whole node, and then you're just telling it to use 4 tasks there. And then you run it. And as I mentioned with the packages, these packages are not installed at NSC. If you're there, you need to install them. It's listed here how. If you're at PDC, they are installed, so you can just run them. So I am going to submit this job here at the SPC2N, and it's called parallel for each. And then kepnikaiser.sh. Let's see, it started running. It may take a little longer because it needs more resources. So I will submit it a couple of times. And one of them is pending, the others are running. I will also submit it here. And I will show you that you can just cancel a job like this. And then it's no longer listed on the pending. Oh, rather, it's still listed because it takes a little while to finish. No, it's but But yes, please try these examples. So you can see it runs, and then afterwards to see that you get these slurm minus job ID out. It is possible to rename the output files, and I think we have examples with that later. Less can also be used to open a file. Here you can see what's going on. It ran just as it should. And there is the RMPI example. It is also much like the other one. It's a parallel one. It has a parallel MPI. It's an MPI, so you need more cores. And there are also some things to tweak, because you need these commands here in order to make it work correctly at UPPMAX. One of them at Citroën, and the same at LUNARC. Then comes NSC, where you need to install this PBD MPI and run it for that instead. That also means that this RMPI program is changed somewhat to use PBD MPI instead. But other than that, it will run. And the same thing at PDC. There also you need to install PBD MPI, and that has to be done outside of R and with all these flags added, because otherwise I could not get it to find the MPI. So, but this works, and then you submit it. So that is very much a similar one, but it's not a bad idea to try or submit several of these, and take also some looks at the batch scripts. If you have your own R scripts, you could try put it into the serial one and have it run it. And remember the input files. There will also be an exercise for one that has inputs. But I am going to submit this one here, the MPI one. And I will also submit one at Tetranet. I named them the same, even though it's not RMPI that's used. And it probably also doesn't run now, because when I was showing you packages earlier, I wiped my directory, which I used, so I probably need to reinstall it here. I can go ahead and do that afterwards. But let's see, it has run. And see what's inside of this one. It works as it should. So that is our programs that use CPUs. What if you wanted to use GPUs? Well, that is somewhat more different between the different centers, because they have different GPUs. They have the way you allocate them done differently. So I will go through this quickly. And UPPMAX, you need to tell it because you are on Rackham, but you are submitting it to Snowy, which has the GPUs. You are telling it these two lines here in the batch script that runs in Snowy, and that you want GPUs. And I actually think the only option right now is one GPU. Is that not the case, Michel?
I don't know.
I believe it is the case right now. And also, when you are then doing SQ minus me, you needed to add minus n Snowy if you are, because you are checking if you have something running, and it will as default tell you about the machine you are on. But on Rackham, you can also be told how it is on Snowy if you add the -m Snowy. At HPC2N, there we have a lot of different types of GPUs and also different number of them, which means that you need to add two lines. One that says how many GPUs, and how many depends on which type. If you don't say what type you want, then you will get a random, which means that you cannot ask for more than two, because what if you ended up on one of those that only has two per node? If you want more, or if you want a specific one, you use this command here, is batch -C, and then which type of GPU. Other than that, everything works the same. On LUNARC has A100 GPUs and also some A40 GPUs, but those are only meant to be used for interactive graphics works on demand. So you should only ask for the A100s. And you do that by adding these two lines here, or if you want the ones that are on Intel nodes, these lines here. There can be one of these that are on the AMD nodes, or one or two on the ones that are on the Intel. At NSC, there are NVIDIA T4 GPUs. To get to them, you say N1 and 32 minus C32, and then how many GPUs per task. Since there is only one type, you just ask for GPUs. Again, at PDC, there are AMD GPUs, only one type. So you ask for the GPU partition, and you say that you want 1 tasks per node and 1 whole node. That way, you get a GPU. And these are some example batch scripts that just have added these lines, so you can see how it works. The GPU script.r does not exist, but this batch script, it does exist here. You could put any GPU script here, and it would probably work. There is, I believe, an example under the machine learning R for GPUs. So you will see it there. And then there is an exercise. You could try to take this serial batch script that was up here. See this one here. That one, take that one and modify it so it would work for the code that is called add2.r. The add2.r is in this directory of files, this one here. I'm just going to open it so you can see how it looks. And one thing to pay attention to in this one is you have two arguments. So remember that when you modify the script, so that you get give it these arguments. And I suggest you try it yourself. Otherwise, there are some solutions for them. And these solutions are also here in this directory. But try it yourself first. So, I think we are a bit over time. I just want to check.